All right, welcome back. This is 6.2 video 2, and we're going to practice a little bit more with some compound growth and some exponential growth. And so what I'd like you to do right now is make sure you grab a calculator. So pause the video and grab out a calculator to help us here. And I'm going to grab my calculator too. All right, so let's see if we can find a formula for if we have $100 and it's growing at a rate of 5% per year. We're just going to work through this, do some actual diving in with the numbers. So with the year 0, our starting point, we have $100. At year 1, we have made 5% on $100, right? We get 5% per year. So we have our original $100 plus 5% more, 5% of $100 more. So I'm going to figure out what 5% of 100 is. I can actually do this in my head, but just to be safe, let's take 100 times 0.05, which is 5, and add that to 100, and we get $105. So after 1 year, if we got 5% a year, we'd have $105. How much would we have the next year? Well, we would have the $105, right? That was what we had from the previous year, plus we get 5% of that $105, right? Because now our investment is $105, not $100. So we earn more each year. So let's take 105, multiply that by 0.05 to figure out the 5%. I got $5.25. Add that to 105, and we get $110.25. All right. So I earned more this year than I did the previous year. The first year, the change was just $5, right? And this year, the change is $5.25 because I have a little bit more money. All right, let's calculate year 3. I'm going to start with $110.25, and I'm going to add to that 5% of that. It's going to be even more than the previous year. So I'm going to take $110.25. I'm multiplying that by 0.05, 5%, and I get $5.51.25. I'm going to round to the nearest penny because we're working with dollars. So I'm going to call that $5.51. I'm adding that to $110.25, which was my last year's amount, and I get $115.76. So this year I gained $5.76. Or no, $5.51. All right, pause the video and see if you can fill the rest of this table out. All right, hopefully you're able to fill this table out. I'm going to do this quickly together. So 115.76 plus 115.76 times 0.05. 115.76 times 0.05 plus 115.76 equals, I messed up. Oops, sorry. Let's try that again. 115.76 times 0.05 plus 115.76 equals 121.55. One more time. 121.55 plus 121.55 times 0.05. $127.63. So as I'm investing this money, I didn't bother to write down the amounts here, but you know they're going up. As I'm investing this money, I'm getting more and more interest each year. And that's the way exponential functions change. They change because you're increasing more each year, because when you take 5% of a larger value, it's a larger number. All right, so let's talk about compound growth and decay. So the formula for exponential compound growth or exponential decay is f of t equals a 1 plus r to the t. Now this is very, very similar to the formula for exponential functions. It is an exponential function. And when we're talking about exponential compound growth and decay, we use 1 plus r because we usually talk about growth rates, and r is the growth rate. But if we want to make this mesh with what we learned about exponential functions, our b value is just equal to 1 plus our growth rate or our decay rate. All right. So a is still your initial value. R is going to be your constant percent change as a decimal. Okay. And t is your time. So let's use this to solve a story problem. Tuition and fees at OSU are currently growing $12,165 per academic year. If tuition increases 5% per year, Predict the tuition in 4 years. So the first thing we're going to do is you could just sit down and compute this by computing after the first year, the second year, the third year, and the fourth year. But what we're actually going to do is we're going to find a model first, and then we're going to use our model. So we're going to find a model, and then we're going to use the model. And we're going to use a formula for exponential growth, because it's growth, right, for this example. So let's see if we can plug this into f of t. F of t equals, A is our initial value. Well, our initial value is $12,165. That's how much tuition is right now. 1 plus, what's our growth rate? Well, it says it increases by 5% per year. So that's going to be 1 plus 0.05 to the t. So there is our model for OSU tuition. So t is years since now, right? And f of t is going to be tuition in dollars. All right, now let's use our model to answer the question. The question is, predict the tuition in 4 years. So that's going to be f of 4. F of 4 equals 12,165, 1 plus 0.05 to the 4th power. And yes, you can add these guys together. You don't see the growth rate separately, but that's the first step would be to add those together. 121.65, 1.05 to the 4th power. Now remember your order of operations when you're computing these guys. Okay, we worked in the parentheses first. That was PEMDAS. Next is your exponent, so you got to compute the 1.05 to the 4th first. And do not round at all. Do not round. If you round, you will lose a lot. I usually just keep the value in my calculator and compute with it. So I type like 1.05 to the 4th power. So x to the y 4th equals, so that's 121.65. And I just leave that value in my calculator. I can write it down like rounded a bit. This is what my calculator spit out, but I actually don't change it. And then I multiply that by 121.65, and I get 14,786.6335, so 63. Now you do round. This is where you do round, okay? Don't round with the exponent. Do round with your dollars, right? Because it doesn't make sense to not have this equal to the even penny. All right, let's try another example. Let's do an exponential decay. The town of Bobsville has been losing population every year since the year 2000 when a new settlement opened up in Sunflower Valley. The population in 2000 was 212,000. By 2001, the population was down to 206,700. If we assume the population is decreasing exponentially, find a model that gives the population of Bobsville as a function of years since 2000. Predict how many people lived in Bobsville in the year 2010. So this one is a little bit harder than the previous one because the previous one gave us by what percent it was decreasing, and this one we have to figure that out. So let's write down what we know. Okay, we know it's losing population, so we know it's decay, right? We know the initial amount in 2000 was 212,000. We know that 1 year later it was 206,700, all right? We have to find a model and use that to answer a question about 2010. All right, so let's go ahead and just put this into a chart. Sometimes that helps me. I'm going to say T is years since 2000. And P of T is going to be my population of Bobsville. And if I make a chart, sometimes this helps me a little bit. And this is my P of T. I know that in times 0, which is in the year 2000, the population was 212,000. And I know 2001, 1 year later, it was 206,700. All right, and I want to know 10 years later, and that's what I need to figure out, big question right there. That's the plan. All right, well, what can I do to figure out this function? Well, right off the bat, let me switch to a different color since I put my information in blue. Right off the bat, I know what the value of my y-intercept is. My a value is right here. So I have that P of T equals 212,000, 1 plus r to the t. 1 plus r to the t. So now I just need to figure out what my R value is. Sometimes it's just as easy to do the B value, but we can figure this out. Well, luckily, there's two ways we could go about this. We can plug in the point that we know, and that's totally fine. Or we can do our ratios. Let's do it with plugging in the point we know. So plug in the point t equals 1, P of t equals 206,700. All right, so 206,700 equals 212,000. 1 plus r, that's what we're trying to find, to the t, which is 1. Well, that's pretty convenient because 1 plus r to the 1 is just 1 plus r. So the first thing I'm going to do to solve for r is I'm going to divide each side by 212,000. So I take 206,700 and I divide it by 212,000. And I got 0.0975. 0.975 equals 1 plus r. Now I'm going to subtract 1 from each side. Excuse me. R equals negative 0.025. So let's plug this into our model. P of t equals 212,000, 1 plus negative 0.025 to the t. That's our model for this Bobsville's population. So is it weird that the r is negative? No, it's definitely not weird. We expected it to be negative because we need this value in here. We need the value inside the parentheses. This should be less than 1 because if it's more than 1, it's going to be growth. It's 100 plus some percent. If it's less than 1, this is decay. So we could actually rewrite this. P of t equals 212,000 at 0.975 to the t. And what this means is that the population is retaining 97.5% from the previous year. So 100% the population would stay exactly the same. If we only retain 97.5%, that means we're decreasing by 2.5% every year. So this is a 2.5% decrease every year. .5% decrease every year. All right, let's zoom out a little bit and see if we can go back and answer the question. We still haven't done this. What's the population going to be in year 10? I'm going to do this right up here. So we need to find P of 10. So that's squishing this in, 212,000, 0.975 to the 10th. And remember, we got to do that part first because that's your exponent. So 0.975 raised to the 10th power is a big ugly decimal. It's like, I need a little more space here. Let's do this. P of 10 equals 212,000, 0.77639, I'm just going to leave that in my calculator and hit times 212,000. So I'm not rounding at all from what my calculator is rounding. And my answer is 164,581.8. If I rounded 2 decimal places. But wait a minute, this isn't money. What is this? It's people, right? We are talking about people. So we do not want to round at all any decimal places. No decimal places. So we're going to round this to the nearest whole person. So that's going to be 164,582 people. All right? So dollars, if you're working in dollars, you're going to round to 2 decimal places. If you're working in people or animals or whole things, you need to round to the nearest whole number. All right, that's it for video 2.